Hello, Geometry Honors. Well, today we're looking at 12.3 surface area of prisms and cones. So first things first, let's get some definitions down. The first definition is what a pyramid is. And I know you can read it for yourself, but it's a polyhedron, so straight edges, polygons, in which the base is a polygon and the lateral faces are all triangles with a common vertex. And then a regular pyramid has a regular polygon for the base. And also the segment joining the vertex and the center of the base is perpendicular to the base. So let's actually move on to, let's draw a picture of each of these. So what's kind of weird is we think of pyramids as being regular pyramids, but they don't have to be. And so to kind of drive home that fact, let's draw a base first. So we've got a base. We'll kind of make it look three-dimensional by making it slanty. So we've got a base. And then to make it a pyramid, I like to draw that vertex up at the top and then connect lines. But we don't have to make it perfectly upright. We can have pyramids be real slanty. So I'm going to draw a really slanty pyramid. And then we'll connect the lines here to make it a pyramid. And this one's going to be behind, so I'm going to make it dashed. And then also this back here is going to be behind things, so I'll make it dashed to show that it's behind everything. So yeah. Oh, hey there, Mr. Van Staveren. I'm actually recording a video, but if you want to say hi. Yep, Mr. Van Staveren, yeah. Well, so class, there's your slanty pyramid. But yeah, that's just a regular pyramid. Pyramids don't have to be straight up and down. And if you've got a pyramid, then you're gonna have, the vertex at the top. You're gonna have lateral edges or side edges. So yeah, there's a lateral edge. Make sure to get this vocab down. You got a base, at the bottom, there's the base. Base edge, base edges. All this vocabulary. And then you've also got lateral faces. So lateral faces would be like there's a lateral face. It's those triangles that you see, those triangles that go up to the vertex. So those are all lateral faces. And yeah, with pyramids, they're going to be triangles. And then to draw a regular pyramid, that's the one that we're more used to. So that's, you're still going to have, we'll draw a slanty box to show, we've got but it would have to be a square. But since we're drawing it three-dimensional, the links don't have to be perfectly equal. But it would be a regular pyramid, so you would have, all regular polygons. So I will put the tick marks. But your vertex should be at a right angle to the base. So you draw it straight up ahead because it's going to be going all, straight up from the center on a regular pyramid. And then you can draw these other shapes. And I may need to go back and make some other things dashed. So I'll erase this to make it dashed. And there we go. So yeah, and then what you got is you got this right here would be a height. And if we were to draw a perpendicular line from the base, climbing up the side of the pyramid, that's going to be our next vocabulary term. That's a slant height. And slant heights are important for finding lateral areas. And yeah, this is a regular pyramid. Okay, so moving along. Yeah, slant height. Here we go. Is the regular pyramid is the height of a lateral face of the regular pyramid, a height of one of the sides, but it's crawling up the side, yeah. And also notice these slant heights are all different, so we don't say that it has a slant height. We don't even talk about it. So a non-regular pyramid does not have a slant height. All right, so now let's draw nets for these. Nets are just like slicing it up and laying it out flat. So you're gonna have a base of a square. So those would all be the same. We'd have right angles everywhere. But then if you lay it out flat, you're gonna have those triangles laying out flat. So it's kind of fun. You got like a little star shape, kind of a petal. And then just to reiterate, that right there is the slant height. And yeah, here's our base. Okay. Now it says draw the net for a regular hexagon. So how many sides does a hexagon have? 6. 4, 5, 6. Since it's regular, they're all going to be the same measure. And then, yeah, we're going to have a bunch of lateral faces that are triangles. And, of course, you got your slant height there. And, yeah, your base. So those are pretty cool. Theorem 12.4 is saying what a surface area of a regular pyramid, how you would find the surface area of a regular pyramid. And I want you to think about that for a second. So, you know, with this regular pyramid, to find the surface area, we would have to, you know, that's like painting the outside. Whoops, we'd be painting the outside. We'd have to paint this triangle, the back triangle, the side triangle. We'd also have to paint the base, the bottom. So surface area, you know, you're really just painting all these triangles and a base. So if you don't have this formula, you can still do this problem. You're just going to realize, oh, I got to find the area of one of the triangles. But because it's regular, all the triangles will be the same measure. So basically multiply by how many triangles you have. That'll be your lateral area. And then you just got to add in the area of the base. Well, they've summarized this as surface area is equal to area of the base plus half the perimeter of the base times the slant height. And that comes from, you know, taking all those areas of all the faces. You can shorten it by just doing 1/2 perimeter times L. Yeah, where L is slant height. So yeah, it's the sum of the area of the base and the areas of the lateral faces, which reduces to this. So yeah, if you want to add more notes there, it's the sum of the lateral faces and the base. All right, so again, if you don't remember this formula, base plus 1/2 PL, just remember, you're just adding up the lateral faces and the base. Okay, let's try one out here. Yeah, so a regular square pyramid has a height of 12 feet and a base edge length of 10 feet. Find the area of a lateral face. So all they want is a lateral face here. Well, so we've got this lateral face staring at me here. And it looks like the base of it, I'm going to draw it out real quick, just one of these triangles. Well, the base of it would be 10 feet, but we need to find the height. And the height is going to be this slant height here, this L. And we don't have it. So how are we going to find it? Well, we've got ourselves a right triangle in here. We've got, so this says it's half of the base, so that would be 5. That would be 5 right there, 5 feet. And yeah, we can do Pythagorean theorem. We can do L squared is going to be equal to 12 squared plus 5 squared, and we can solve for L. Turns out L is going to be just 13. And then to find the area, the lateral area is 1/2 base times that height we just found. And we're going to get 65 feet squared. And that's just one of the lateral faces. If we wanted to get the total area, that wouldn't be too difficult. We could multiply that one face by 4, because there's 4 of them, and add in the area of the base. You'd be done pretty quick. Okay, on example 4, it says find the surface area of a regular octagonal pyramid if the slant height is 18. They got that labeled for us. That's nice of them. The apothem of the base is 15.7. They labeled that for us. They're so kind. And the sides of the base are 13 feet. Okay, so to get the total surface area, we're going to have the area of the base plus the lateral areas, or we can also think of it as a half perimeter times slant height. So for the area of the base, it's going to be, this is a regular polygon, so we can do 1/2 apothem times perimeter. Yeah, okay, so we're gonna be able to figure this out pretty quick. I think we have everything we need to know. So the apothem was 15.7. The perimeter would be, let's see, so 13 times 8. 13 times 8, that is 104, I believe. Yep. And then plus, we've got 1/2, and then the perimeter is 104 again, times the slant height, which was 18. And by golly, we're ready to crunch those numbers. Yeah, so I think, I think we get 816.493. Okay, so 1,752.4 feet squared is what I get for that. And again, class, you don't have to do this 1/2 PL. You could just think about it. Oh, find the area of one of the triangles, multiply it by how many there are. In this case, there'd be 8, and it'll get you the same answer. Okay, now we're going to talk about cones. Cones are just like pyramids, except they're not a polyhedron. They have curves. They have a cone has a circular base, and then it's got a vertex just like a pyramid does. And then the height of a cone is the perpendicular distance between the vertex and the base. So here's what's fascinating. Well, no, I'll take it back. So yeah, well, I was going to say something about volume, but we're not in volume yet, so I won't talk about that yet. But in a right cone, the segment joining the vertex and the center of the base is perpendicular to the base. So it's going to be straight up and down. And the slant height is the distance between the vertex and a point on the base edge. Okay, so we've got a cone. I draw cones by drawing an angle and then rounding it off, making it look three-dimensional. There we've got a cone. It's going to be a right cone if the distance there to there is a right angle. And yeah, we got a slant height as well, a slant height there. To draw a net for it, it's kind of interesting. So basically you got your base, but then you're gonna snip up a side and then lay it out flat. And when you do that, you basically get a Pac-Man. So it's kind of cool. So yeah, if you can imagine, closing this gap and then sitting it on top of that base, you would have the same shape. So what's kind of fun is this right here is going to be, the circumference, the same as going all the way around here. You got a radius here for the circle. And where we cut along the side, that's our slant height. So it's kind of cool to see that all on your net. So the surface area of a right cone is very similar to the formula that we got for surface area of pyramids. Yeah, I mean, it really is. So instead of perimeter, we've got circumference, and that's the only difference here. So basically, yeah, it's going to be, let me write it out. Surface area is going to be, so it's the area of the base, but since it's a circle, we're going to write pi r squared plus 1/2 perimeter L, but because it's 1/2 and then the circumference is 2 pi r, they cancel out, the 1/2 and the 2 pi r cancel out, and we're left with pi r L. That's the formula for that. The pi r L is the lateral area. Okay, so notice that's really similar to this. It's just that in exchange of P, you write 2 pi r, the 2 and the 1/2 cancel, and you're at pi r L. So it's the same formula, just with circles. Okay, so let's flip it over and work some of these out. What is the surface area of the right cone? Well, surface area, we just learned, is equal to pi r squared, area of the base, plus pi r L. We've got the radius, so pi 10 squared plus pi 10. But we need our slant height. We don't have our slant height. But because it's a right cone, we can figure that out pretty quick by using Pythagorean theorem. And beep boop bop boop beep, 11 is 20, or I'm sorry, the slant height is 26. And we can get our answer in terms of pi here. It's going to be 360 pi centimeters squared, or we can round our answer and get a not quite exact, a non-exact answer, but maybe in some people's opinion, a more useful answer. And if we round it to the nearest tenth, it's 1,131.0 centimeters squared. So it should tell you which answer they want. All right, on the next example, it says a carpenter uses a weight in the shape of a right cone to identify vertical lines. And I have seen this before. It's pretty cool. I think they call it like a plumb line or something like that. The cone has a radius of 6.5, so we actually got to label it this time. So 6.5 millimeters, and a height, so from there down, a height of 13 millimeters. Find the approximate lateral area of the weight. Since we're just doing lateral area, we just need to do pi r L. We've got the radius, but we're missing the slant height. So I think we're going to have to do Pythagorean theorem again. It said it's a right cone. So yep, let's knock that out. So L squared is equal to 6.5 squared plus 13 squared. And L is going to be, I'm not going to round yet, it's going to be square root of 211.25. So that's exact. That's exact. I don't want to round midstream. So and then when I fill this in, I'll have pi. The radius was 6.5. And then L is square root of 211.25. And when we multiply that all together, I'm going to go ahead and get a decimal answer because this is not going to be super nice, I don't think. So I'll go ahead and get go straight to a decimal answer of 296.8 millimeters squared. So hopefully you agree with that. And then we got a couple more here. We got a right cone. So I'm going to draw it out. A right cone straight up and down. To get to the height, it's going to be a right angle right there to the middle. Right cone with a radius of 8. Got it. And a surface area of 224 pi meters squared. Find its slant height. Oh, interesting. So we're working backwards. Well, surface area is equal to pi r squared plus pi r L. But we know that the radius is 8 meters. We know that the radius is 8 meters. And now we're ready to solve this. So I am not going to get decimals yet. I'm going to go ahead and subtract 64 pi from 224 pi. Those are like terms, so that's cool. So when I subtract the 64 pi from the 224 pi, I get 160 pi. And at that point, it's still equal to the 8 pi L. That's the customary way of writing things in terms of pi. And then I still need to divide by the 8 pi, divide by 8 pi, and the pi's divide out, which is pretty sweet. And we get 20 meters. 20 meters right there. I should have kept the units on there so you can see how they divide out to make meters. But anyway, our slant height is 20 meters. Hopefully that you agree with that. And then on the last one, it says find the surface area of the regular pyramid. So we're back to pyramids. So the surface area is going to be equal to area of the base plus the area of the faces, but we can also do 1/2 pi perimeter L. Yeah, either area of the faces all multiplied together, multiplied by how many there are, or you can do 1/2 PL. And in this, it says it's regular, so we know it's 10 by 10. So to get the area of the base, we'll do 100 centimeters squared plus 1/2. The perimeter is going to be 40, and the slant height is 15. They gave us everything we needed, didn't they? And I get 400 centimeters squared. All right, so class, your practice is somewhere. It'll be on Canvas. Have a great day.